Hi, this is Luke Johnson again, and in this video I'm going to be discussing how we can monitor iron corrosion with a turbidimeter and how we can calibrate the turbidimetric data with total iron data. Now, as I said in the application overview video, iron corrosion is generally present, greater than 90% present, as particulates. And the two main particulates are these iron oxides, hematite, which is red, and magnetite, which is black. Now, part of the limits of a turbidimeter in this application is that turbidimetry and nephelometry is not measuring iron specifically. It is measuring any particulate that will reflect light at 660 nanometers. In the steam cycle, we make the assumption that the overwhelming majority of particulates present are iron oxides, but we have to go one step further and perform an on-site calibration because a nephelometer will respond differently to different colors and different sizes of particles. For instance, the red hematite will reflect more light than the black magnetite, which will absorb more light, which means that for an equal concentration of iron, if it were present as magnetite, you would get a lower nephelometric response, indicated up here on your controller, than you would for the same concentration of iron if it were present as hematite. As I said earlier, the ratio or the concentration of these two oxides is dependent upon the chemistry in your particular plant or even in your particular location within your plant. So depending on the age or the flow characteristics, whether you're running a reducing or an oxidizing chemistry or feeding some type of oxygen scavenger, you may have more magnetite or more hematite. What that means is that in order to make this number, which reads out in milli-NTUs, mean something for an iron concentration, you'll need to do a calibration of that number with the lab total iron test. So what I'm going to show you now is how you can do that, how you take the sample, which is not very difficult. And once we take the sample, in the next video I'll show you how to analyze that sample with the lab method. And then once you have that data, you can plug that into a simple linear equation, which is outlined in the calibration guide available on the Hach.com website, and that will calibrate milli-NTUs to parts per billion iron. It's important to know that this calibration is only good at a steady state condition. Once you install one of these and maybe you cycle or you turn a valve, you'll notice rather than a steady background of turbidity, that a large peak might come through. This is regular at almost every application, every installation that we've ever done. When power cycles up or down, a spike of particulates goes through the turbidimeter. Now that spike is not due to iron corrosion at regular steady state conditions, and that means that those particulates are not the same particulates and not in the same ratio that you would see at a steady state in a steady state scenario. So the calibration which we're going to perform assumes that you're running at a steady state and is also not applicable outside of that steady state. Again, we have a paper available on the Hach.com website that describes this application in greater detail and the limitations of this calibration. But feel free to go to the website and download that for more information. So right now we're going to do the sampling here. I have these 5 20 millimeter vials that I discussed in the previous video, and I've marked them 1 through 5. The first one I've designated as a blank, and I've just filled this with high purity iron-free water. And now I have these marked 2 through 5. Then I'm just going to take the sample right here from the turb outlet as the water falls into the drain filter. I'm going to rinse the vial a few times with the sample, and then fill to the line that I've marked for 15 milliliters. I'm going to do that with 4 consecutive samples, again assuming that we're at a steady state so that the turbidity value hasn't fluctuated greatly for a period of 20 to 30 minutes prior to the sampling. So in the next video, I'm going to show you how to run these samples. And as I said earlier, with the data that we get from those samples, you can plug that back into the calculation in the calibration guide and obtain the linear calibration to correlate parts per billion total iron to millinephthalmetric turbidimetric units.